In this review tape, we're going to be going over our work on graphing. We're going to be sketching graphs of lines, parabolas, circles, ellipses, hyperbolas. If you need to see more work on this material, then we suggest you go back and look at the original videotape lessons on these curves. Okay, in each of the following, we're going to try to identify the curve, sketch it, and when we're sketching it, we're going to label intercepts, vertices, centers where appropriate. Okay, the first example is 4x plus 16y equals 16. Okay, now coming as it is just like this, most of you could probably recognize this as the equation of a straight line. And if asked why is it a straight line, well, maybe you would say, I don't see any squares or something like that. In other words, x and y are to the first power. We have a first degree equation in x and y, and the graph of such an equation is going to be a straight line. Now, a straight line is determined by 2 points, so all we need is to sketch, plot 2 points on the graph, and then we can connect them and get the straight line. The easiest points to get would be the intercepts. So we can say let x equal 0 and solve for y. If x is equal to 0, we get 4 times 0 plus 16y equals 16. 4 times 0 is 0, so 16y equals 16. Y equals 1. That is the y-intercept. So it goes through the point, in other words, 0, 1. 1 is the y-intercept. Similarly, we can set y equal to 0 and find the x-intercept. If we set y equal to 0, we get 4x plus 16 times 0 equals 16, or 4x equals 16. X equals 4. X equals 4. 4 is the x-intercept. And this means that the curve goes through the point, or the line goes through the point 4, 0. So we have the x-intercept and the y-intercept. Okay, it goes through the point 4, 0, 2, 3, 4. The x-intercept is 4. It crosses the x-axis at 4. And it goes through the point 0, 1. The y-intercept is 1. It crosses the y-axis at 1. And just connecting, we get the graph. Looks like that. Now, in our next example, I'm going to change this a little. I'm going to make it 4x squared plus 16y squared equals 16. Okay, now while you might have known that 4x plus 16y equals 16 should be a straight line, okay, it sort of gets a little confusing when you see a few of them together and they all look similar, but there's slight differences. It might be helpful to consider the various possibilities that we can get. If we have, say, ax plus by equals c, an equation that is first degree in x and y, okay, the graph of such an equation is going to be a straight line. A, b, and c are constants, and a and b are not both 0. On the other hand, okay, if we have ax squared plus by squared equals c, okay, a, b, and c, but now x and y are both squared, okay, we have various possibilities. We might have a circle, we might have an ellipse, and we might have a hyperbola. And what it is depends on the coefficients, the constants a, b, and c here. Okay. If a, b, and c have the same sign, a, b, and c have the same sign, and a equals b. Okay, so it's a circle if a, b, and c all have the same sign. They're either all positive or all negative, and furthermore, a equals b. And we'll see an example of that a little later on. Here, a, b, and c have the same sign. They're all positive, but a is not equal to b. This is an ellipse. Okay? If A, B, and C have the same sign and A is not equal to B, then we have an ellipse. And that's what we have here. A, B, and C, same sign. A is not equal to B. And finally, the last choice, hyperbola, if A and B have different signs. Okay, so when both x and y are squared, it can be either a circle, ellipse, or hyperbola. And although we're not going to see it right away, a little later on in the tape we're going to come to parabolas. And if, say, x is squared but not y, or if y is squared but not x, in either of these instances, we would have a parabola. And it is also possible that there would be, for example, here, if there's x squared, this also could be a first-degree x term. It would still be a parabola. It would have the effect of moving its vertex. Same thing here. Y is to the second degree. It could also appear, a first-degree term in y. Okay? It would still be a parabola. The key to knowing it's a parabola is if one of the variables is squared and the other one isn't. Okay? X or y is squared. The other one only appears to the first power. Okay, so that's sort of a summary of the different types of situations that can arise. And as I mentioned, the one that we did, the first example, of course, was first degree in x and y, no squares at all. That would be a straight line. This one we have here, both x and y are squared. Okay, it's one of these, and it comes under the second category. A, B, and C have the same sign, and A is not equal to B, so it's going to be an ellipse. Okay, so let's get down to the business of sketching this one. Okay, now I gave it to you in the form ax squared plus by squared equals c. Alternately, sometimes you see the ellipse written in the form having divided through by the number on the right-hand side. If you were to divide through by 16, if every term were to get divided by 16, this would give rise to x squared over 4 plus y squared over 1 equals 1. I got from the original equation to this by simply dividing through by 16, the number on the right-hand side. Okay, so these are different equations of the same ellipse. You can see it in this form or in this form. It doesn't matter. Okay, let's say we had it in the original form. The key to sketching the ellipse would be to, once again, get the intercepts, just like with a straight line. The x and y intercepts told you the whole story. And once you know it's an ellipse here, the x and y intercepts are going to tell you the whole thing. Okay, so we let x equal 0 to get the y-intercepts. And when we let x equal to 0, we get 4 times 0 squared plus 16y squared equals 16. 4 times 0 is 0. 16y squared equals 16. Y squared is 1. Y is plus and minus 1. We have 2 y-intercepts. And similarly, we can let y equal to 0 and solve for x. We get 4x squared plus 16 times 0 squared, or 16 times 0 is 16. 4x squared equals 16. Dividing through by 4, x squared equals 4. X equals plus or minus the square root of 4 plus or minus 2. We have 2 x-intercepts and 2 y-intercepts. And when we try to sketch this, we put down the 2 x-intercepts of plus 2 and minus 2, and the 2 y-intercepts of plus 1 and minus 1. And we try to draw the ellipse through these 4 points. Something like that. Okay, now don't get sloppy when you're taking, when you're solving for y here. Don't forget to go plus and minus 1. If you only get one x-intercept and one y-intercept, you're going to think it's a straight line. Okay, so don't forget, when you have the quadratic, you get these two intercepts for the x-axis, 2 for the y. Okay, what about this one? 4x squared plus 4y squared equals 16. Okay, just like in the previous example, we have ax squared plus by squared equals c. Okay, so it's either a circle, ellipse, or hyperbola. Here, a, b, and c all have the same sign, and furthermore, a equals b. The coefficients of x squared and y squared are the same, so we have a circle. In this case, we can divide through by the common coefficient of x squared and y squared. Dividing through all parts by 4, we get 4x squared over 4, or x squared, plus 4y squared over 4, plus y squared equals 16 over 4, or 4. And we recognize this, of course, as a circle with center at the origin and radius 2. If you wanted to think of it in the x minus h squared plus y minus k squared equals r squared business, the center here is at hk. This is like x minus 0 squared plus y minus 0 squared is r squared, or 2 squared. The radius is 2. But ultimately, we could still get the x-intercepts and the y-intercepts here. Whereas if we set x equals 0, we would get y squared equals 4, for which we'd get y equals plus or minus 2. And if we set y equals 0, we would get x squared equals 4. Set y equals 0, this drops out. We have x squared equals 4. X is plus or minus 2. And we can see a certain similarity between the ellipse and the circle. The only difference here is that in the previous problem, the x-intercepts and the y-intercepts were different. In other words, the x-intercepts were 2 and minus 2. The y-intercepts were 1 and minus 1. Okay, we had sort of like a squished circle. Here, the x-intercepts are 2 and minus 2. The y-intercepts are also 2 and minus 2. And we get our circle. As I said, center at the origin. Well, center at the origin, radius 2. It's supposed to be a circle. I'll write circle so we'll all know it's a circle. Center is at 0, 0, and the radius is 2. Okay, but you can, in a pinch, do this with the intercepts as well. And the x and the y-intercepts being the same gives us the circle. In our next example, we have 4x squared minus y squared equals 16. Once again, in the form ax squared plus by squared equals c. But here we have a and b with different signs. A is plus 4 and b is minus 1. The coefficients of x squared and y squared have different signs. Okay, and this immediately classifies it as a hyperbola. We can say, well, if y equals 0, we will find the x-intercepts. We say 4x squared minus 0 equals 16. 4x squared is 16, dividing through by 4. X squared is 4. X is plus or minus 2. 2 x-intercepts. And here, if we set x equal to 0, we get 0 minus y squared equals 16. Y squared equals minus 16, multiplying both sides by minus 1. And we try to take the square root. We can't, because we cannot take the square root of a negative number. Would not be a real answer. So there are no y-intercepts. No real y-intercepts. Now, in sketching the hyperbola, and by the way, this is not too hard to believe, after all, we would expect something like, well, we have 2 x-intercepts, 2 and minus 2, and no y-intercepts, and this sort of goes along with what we feel the hyperbola should look like, something like so. 2 x-intercepts here and no y-intercepts. So the intercepts are very helpful. If you forget any of the rules about the A, B, and C business, the intercepts will help you out in a pinch. Now, although there are x-intercepts and no y-intercepts, we can still use the information here to help us get a better sketch of the hyperbola. Okay, you may say, well, the x-intercepts are 2 and minus 2. How do you know if the hyperbola should look like this? Or maybe it should be narrower, or perhaps it should be wider. How do you know which way to draw it? Well, there is a trick way to, it's a way to find it. One can prove that it actually works out, but we're not going to do that here. I'm just going to give you a sort of a neat way of getting a good sketch of the hyperbola. What we do is the following. We say, well, the x-intercepts are 2 and minus 2. There are no y-intercepts, because you can't take the square root of a negative number. But suppose this had been a plus 16. If this had been a plus 16, if y squared had been plus 16, y would be plus or minus 4. These are sort of like phantom intercepts. Okay? They're not really there. Okay? You say, what if this had been a plus? Then the intercepts would have been plus and minus 4. 1, 2, 3, 4. 1, 2, 3, 4. Now, these aren't really intercepts here. But if you were to draw a rectangle going through the 2 real intercepts and the 2 phantom intercepts, like so, there's only one rectangle that we can fit through the 2 real intercepts and the 2 phantom intercepts. And then if you were to sketch in the diagonals of this rectangle, the diagonals of this rectangle are guidelines for drawing the hyperbola. Now, these are the real intercepts. Don't lose sight of that. These were the phantom ones. The phantom ones were just used so that we could draw a rectangle through the real intercepts and the phantom intercepts. The diagonals of this rectangle are what we call asymptotes for the hyperbola. Lines that the hyperbola is going to get very close to, but not quite touch far out. And this gives you an idea of how wide or narrow to make the hyperbola. In other words, have it come in. It should be continued here, and it's sort of hard to fit it in. But have it come in through this real intercept and use the diagonals as a guide as to how wide or narrow the hyperbola should be. Through this intercept, like so. Okay, so use the diagonals as a guidelines for drawing the hyperbola. Remember, there are only 2 intercepts, 2 real intercepts, 2 and minus 2. And that helps you to remember that it is a hyperbola. But if you were to put in the imaginary intercepts, okay, draw the rectangle, you would have guidelines. By the way, changing this from a minus 16 to a plus 16 is like changing this here to a positive. And if this had been a plus, the curve would have been an ellipse. And it would have been the ellipse that went through the 2 real intercepts and these 2 phantom ones. It's sort of like lurking inside of every hyperbola. We have an ellipse in there, in that rectangle. Okay. Our next example will be the following. 4x squared plus y equals 16. Okay, and the first thing to notice here is that x is squared, but y isn't, and therefore this is going to be a parabola. You see that immediately because x is squared, but y isn't. X is to the second power, y is only to the first power. Okay, well, once I know it's a parabola, we can use the information that we learned in class for sketching the parabola. In particular, we know that the x-coordinate of the vertex is given by the formula minus b over 2a. where we think of, this is only if the parabola is in the form y equals ax squared plus bx plus c. Okay, so let's put the parabola into that form. We'd have to solve for y. Y is equal to, transposing the 4x squared, minus 4x squared plus 16. Okay, all I did here was to subtract 4x squared from both sides, giving me y equals 16 minus 4x squared, and then try to rewrite it in the form the x squared part, then the x terms if there are any, and then the constant. So minus 4x squared plus 16. From this we see that a, the coefficient of x squared, is minus 4, b is 0, and c is 16. And the x-coordinate of the vertex is minus b over 2a, minus 0 over 2a, 2 times minus 4. The x-coordinate of the vertex is 0. And if you want to then find out where the vertex is, it's x equals 0, y equals, well, to figure out what y equals, you substitute x equals 0 into the equation. If x equals 0, y is equal to 16. So here we have the coordinates of the vertex of this parabola, or the turning point of the parabola. Okay, now if we wanted to find intercepts for the parabola as well, to get the y-intercept, we would set x equal to 0. And of course, when we set x equal to 0, we would get y equals 16. So not only is this the vertex, but it's the x-intercept also. Excuse me, the y-intercept also. We set x equal to 0. We solve for y. That's the y-intercept. It's the vertex, and it's also the y-intercept, 16. To get the x-intercept, okay, we let y equal 0. Then we'll get, you can go back to the original equation or this one here. Back in the original equation, we have 4x squared plus y equals 16, or 4x squared plus 0 equals 16. Dividing through by 4, x squared equals 16. X is plus, dividing through by 4, excuse me, x squared equals 4. X is plus or minus 2. Okay, so we have two x-intercepts. Okay, so let's see what we have. Let's put it all together for the picture. The y-intercept is 16. The x-intercepts are 2 and minus 2. And 0, 16 is also the vertex, or the turning point of the parabola, and the parabola is opening down like so. In our next example, we have y equals x squared minus 8x plus 16. And once again, we see that x appears to the second power, but y only appears to the first power, and therefore it is a parabola. When x is squared and y is not, or y is squared and x is not, okay, we have a parabola like this. And it's already in the form y equals ax squared plus bx plus c, so we'll be able to determine the vertex directly. A, of course, is 1, and b is minus 8. And the x-coordinate of the vertex is minus b over 2a minus minus 8 over 2 times 1, 8 over 2, or 4. So the vertex is x equals 4, and when x equals 4, we can substitute in to figure out what y is. Y is equal to x squared minus 8x plus 16, or 4 squared minus 8 times 4 plus 16. That gives us 16 plus 16, 32 minus 32, 0. X equals 4, y equals 0, or the coordinates of the vertex or the turning point. Okay, now to get the intercepts as well, if you set x equals 0, you would get, of course, y equals 16. That is the y-intercept. And if you set y equal to 0, you'd get x squared minus 8x plus 16 equals 0. This is a quadratic equation which can be factored. X minus 4 times x minus 4 equals 0, giving us x equals 4 in both instances. So if y equals 0, the x-intercept is 4. And the x-intercept turns out to be the same as the vertex here. And we put the whole thing together to draw a picture. We have, when x equals 0, y equals 16. That is the y-intercept. When x equals 4, y equals 0. That is the x-intercept. And furthermore, this is 4, 0 is also the vertex or the turning point of the parabola. And it looks something like so. Comes down here and continues up. You can, of course, get a few more points if you'd like to. If you feel it would make it a little more accurate, you could plug, substitute in x equals 2, 3, 4, 5, 6, and so on, just to get a better idea of what's happening. But there's basically the situation. Unlike the previous example where there were 2 x-intercepts, okay, here we have a situation where the turning point is on the x-axis. This is example 7. X squared plus 6x plus y squared plus 5 equals 0. Okay, don't get confused and say, well, here is x to the first power and y to the second, so it's a parabola. We're looking for the highest power, and we see that x is to the second power and also y. Okay, so that puts it under the category of either circle, ellipse, or hyperbola. Furthermore, the coefficients of x squared and y squared are the same. Okay, so if it has a real graph, it's going to be a circle here. And I say if it has a real graph because I'm not 100% sure when I finish completing the square and I get the radius that I'm going to get a positive number on the right-hand side for taking the square root. But if I do, then this is going to be a circle. Okay, so it is a circle. And what we want to do here is keep the x terms together, the y terms together, and any constants to bring them over to the other side. And we're going to complete the square here. So let's write this as x squared plus 6x plus y squared equals minus 5. And to complete the square, we take the coefficient of the first degree term, which is 6. We take half of that, which is plus 3. We square it, get 9. And that's what we add to both sides of the equation. Here I don't have anything to do because it's just 0y. So we're going to add half of 0. It's just going to be 0 here. We have x squared plus 6x plus 9 plus y squared equals plus 4. Now, the whole beauty here is that this is really just x plus 3 squared. X squared plus 6x plus 9. It's now a perfect square. Y squared, think of it as, say, y minus 0 squared equals 4, which you could think of as 2 squared, in an effort to make this in the form x minus h squared plus y minus k squared equals r squared, the center radius form of the equation of a circle. From this, I can see that the radius is 2. Now, the center, okay, careful here, it's going to be the opposite sign. I need x minus h, and then hk, the coordinates of the center. So think of this as x minus a minus 3. Minus 3 is your h. So the center is at minus 3, and of course k is just 0. We have a circle, center at minus 3, 0, radius 2, and let's sketch that. The center is at minus 3, 0. The radius is 2. So I go to the right 2, to the left 2, up 2, and down 2 to get points on the circle. And then I sketch the circle. And the last example on this tape is the following. Example number 8. Y equals x squared plus 6x. Since x appears to the second degree but y only to the first degree, we have a parabola. And matching it to y equals ax squared plus bx plus c, we have a equals 1 and b equals 6. So the vertex is found x equals minus b over 2a, minus 6 over 2 times 1, or minus 3. And the y value, when x is minus 3, substituting into the equation, x squared plus 6x, we get minus 3 squared plus 6 times minus 3, x squared plus 6x. That is 9 minus 18, or minus 9. So the vertex is at minus 3, minus 9. To get the x-intercept, we set y equal to 0. We can start with the setting x equal to 0 to get the y-intercept. If x equals 0, y equals 0 squared plus 0, y equals 0. This is the y-intercept. And if y equals 0, we get x squared plus 6x equals 0, a quadratic equation which we can solve by factoring, giving us x equals 0, x equals minus 6, 2 x-intercepts. And let's see what we have. We have a vertex at minus 3, minus 9. Minus 3, minus 9 is the vertex. We have y-intercept at 0. X-intercepts of 0 and minus 6. 1, 2, 3, 4, 5, 6. And of course the parabola is going to be opening upward through this vertex and continues in either direction. And that brings us to the end of this tape.